All right, so we're going to get into Unit 4, starting with set builder notation. And by the end of this, you should be able to understand domain, range, and the linear relationship between the two, and write inequalities using what we call set builder notation. And well, first you have to understand, we'll review what domain and range is, and we'll define what a set is, and then we'll talk about what all these signs over here that we have down here, what all those things are. Oops. And then we'll refresh your memory on all these different terms over here on the right. But first, so what is set builder notation? Well, so mathematicians like to write in a very condensed manner with symbols and things like that. And words are cumbersome when writing down. And they take up a lot of space. So we try to write as little as we can in a condensed manner with symbols. So we like to use shorthand as much as we can. So set builder notation is a shorthand used to write sets, especially if it's an infinite number of elements, right? So like the set of x such that x is greater than 0 would be read aloud. The set of all x such that x is greater than 0 is read aloud exactly the same way with a colon when replaced with this vertical line thing. So I'll talk about that this replaced all of this, right? So that's a seriously condensed version of the words. Okay, so that's kind of illustrates my point there. All right, so let's again talk about the domain. Remember, domain is all values of our left and right axis, typically x, right? Typically x, where x can live, x and y, or x, right? Sometimes it's infinitely x, left and right. Sometimes it's right. It's sometimes it's just a finite number of numbers, right? But it's the left and right are x values, right? And then our range, so this is the domain, right? And then our range, R-A-N-G-E, our range is the y, or the vertical axis, okay? So more specifically in the terms of functions, right, our domain is the possible sets, of input, or the possible input sets. So the possible input sets, or sets of inputs. Okay, and then the range is given that input sets, given the possible domain of a function, it's the possible output sets. So that leads one to think, well, what is a set? Well, a set is just a group of numbers. It's just a group of numbers. Right? And it can be an infinitely large set, or it can be a finite set of numbers, right? So when we can say, like, so here's a visual representation of a set, right? You can have like 3, 4, 5, 6, and 7. That's a set of numbers. Okay, and we have different types of numbers. Remember, we have natural numbers. Okay, and those are numbers like are just 1, 2, 3, 4, 5. Right? They don't have any like different like decimals or something like that. And a natural, T-U-R-A, natural numbers. Let's see if we can get a better, N-A-T-R-U-A-L, natural numbers, N-U-M-B-E-R-S, natural numbers. According to Google, natural numbers are, they start with 1, end with infinity, and they just kind of nice and round numbers. They don't have any real decimals. More specifically, they're just number used for counting, and they're positive, right? So anything greater, like 1 through whatever, positive numbers, and they're so the first numbers you learn, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so anyway, I think I beat that. Those, the symbols for those are N. You'll be learning those in your set builder notation. Say whole numbers. So whole numbers can include 0, and that's really the only difference. Okay, and they don't have a symbol. There's no symbol for whole numbers. Okay, integers are kind of like natural numbers or whole numbers, but they include negative numbers, and they have a Z as a symbol when we're writing them in set builder notations. Then where there are rational numbers, and remember, rational numbers come from a ratio or a fraction, right? They can come from a fraction. Right, so if they come from a fraction, something that is derived from a like a repeating decimal, or a decimal that, like this is a 4 and 1 over 100, right? If they can come from something that is a rational number, then it is a rational number. Those have a Q. Irrational numbers, on the other hand, come from something that does not have a repeating decimal, or do not come from a fraction, right? If it's not a repeating decimal, like pi or anything like that, these don't have a symbol. And then you have all real numbers, and this includes anything on the number line, anywhere. And this is R. Okay, so you have N, Z, Q, and R. Are the ones you really have to worry about with natural numbers, integers, rational numbers, and real numbers. Okay? All right. So, some new terms or new symbols you might learn is the colon and this up and down line, and you read that as such that. And then you have this like elongated E, and you would read that is an element of, and that would be combined with one of these symbols, right? And I'll show you an example of that here. And then these curly braces, this is what confines the set, right? So this is what confines the set, right? So, for example, let's say we had a line. Let me go grab a ruler. Pause it for a second. All right, so say I have this line here, and it has these 4 points on it with my y-intercept and my x-intercept, and I'm able to determine that this is my where this is a line segment. This is where this line segment exists. It starts here and it ends here. Okay, I'm not going to go into the slope of this line or anything like that. I just want to determine the range and the domain of this line segment. Okay, so in order to do this, you can kind of visualize a box where this thing lives. Okay, this thing kind of lives in a box here and here. This is the maximum and minimum in the y direction, and this is the maximum and minimum in the x direction. It lives inside this box here. Okay? Well, this maximum and minimum in the y direction is the range. Okay, and the maximum, and this is the range. And then this blue part here is the domain. Okay, so the respective x's is the maximum and the minimum, what that the domain, the inputs that could be for the respective outputs of y. Right, if you look at what we said for domain and range up here, we said domain and range is my domain is my possible inputs. My domain is my possible inputs. That's my x values. And then my range is my possible outputs because of my possible inputs. Okay, so wish I had blue. So to write this in layman's terms, right? My minimum is -4 for my domain. Okay, and my maximum is 6. Right? So my x has to be between or including that -6, between -4 and 6, right? And a resulting output of that, if it was 4, it'd be -2/3. If it was 6, it would be +6. My y value would fall in between there somewhere. Okay, if it was like right here somewhere, it would spit out whatever number that is. Right? If it was here, it would spit out whatever number that is. Okay, so that's how functions work. Right? So this is the inequality that exists. It's got to be between -4 and 6, as a resulting -3 and 6 for my y value. All right, so to put this in a set builder notation, we can call this like set A. We'll call this set D for domain. We'll call this set R for range. Okay, set R for range. All right, so my set D equals, right, you got to do your fancy curly brackets. I gotta open this up. I'm gonna write in a pen. Let's imagine that this is purple or is blue. Right? Set D is all values of x such that, right? All values of x such that x is, or such that x is, excuse me, so -4 is, keep forgetting to write -4, such that x is greater than -4, but less than or equal to, greater than or equal to -4, less than or equal to -6. Okay? And is an element of, gotta make my, that looks like a sigma, and is an element of all real numbers. And then I'll close my brackets. Yeah, so that's real big fancy way of how to do that, right? Because it's all real numbers, all real numbers. So rational and irrational numbers. Okay, and then my range is all values of y such that y is greater than or equal to 2/3 but less than or equal to 6 and is an element of all real numbers. Okay, kind of like that. All right, so that's how you do it. You'll see stuff like that all throughout this lesson plans. Doesn't come up too often, but that's how you do all that is an element of such that. And it's kind of hard to say when it's stuck in between here, right? But if it includes an infinity sign, y cannot be less than or equal to infinity, right? It has to be y is less than infinity, or y is greater than negative infinity, right? They're not ever equal to infinity because it can't be equal to infinity. Okay, so that's one little tidbit. Hope that makes sense. And we'll move on to the next lesson now.